Hi everyone, it is now time to take off and start working with some data. So we're going to explore concepts of data management, data preparation, and data wrangling, and you're going to get an opportunity to start getting your hands dirty using Excel and R. So the big idea here is that successful data analysis is contingent on successful data management. The most common data management approach, it's databases. That's why we have an entire class dedicated to them. Knowing what you have, whether it's in a database or not though, requires inspection and evaluation. And we're going to practice these skills this week. In fact, sometimes knowing what you don't have and how you handle those missing or unknown values is as important as what you do have. And sometimes what we have isn't the most useful format, and we have to conduct transformations to our data to put it into a format that is more useful to us. So we're going to cover and walk through ways that we can address every single one of these issues this week. So here's a scenario. Catherine is a marketing manager at Organic Foods Superstore, or we can just call it Whole Foods. She wants to market a new line of Asian-inspired meals to college-educated millennials, and she's acquired a representative sample. She wants to use the data to identify Organic Food Superstore's college-educated millennial customers and compare profiles of female and male college-educated millennial customers. So I suggest opening up the Excel file in this module called Customers, and let's take a look at what we have. And while you're looking at the data, think about whether we could use this to identify college-educated millennial customers, with what components of the data set, and do you think we could compare the buying profiles of men versus women with this data, and which variables might help with that? It is common in data sets, especially those that may not have been collected by you, to have a whole range of variables. And the fact is, you're not probably going to need or want to use every single one of those variables. So part of the data management process is taking a look at the data that you have and thinking critically about each of the variables and figuring out, will this actually help me accomplish my end goal? So I encourage you to open up the customer's data set in Excel and think about these questions. So an increasing volume and variety of data means that organizations are dedicating more and more time and resources gathering, cleaning, and organizing data before they're able to perform an analysis. And as the amount of data grows, which it is, the need and difficulties of data wrangling increase. Suddenly we find that we need experts in data analysis and data management, that this task is now growing beyond the role of a regular office administrator. Difficulties with cleaning and organizing big data or even just large data sets are a major barrier that prevents organizations from taking full advantage of what information and knowledge might be held within the data that they're already collecting. And in fact, we find that business analytics professionals today spend more than half their time collecting and preparing unruly data. It is the exception and not the rule that you'll be handed a perfect, beautiful data set that requires no additional work on your part to prepare for analysis. This means that business analytics professionals must be self-reliant and have skills for data wrangling and analysis. And that's more than just being a statistical whiz. So if statistics and math isn't your strong suit, but you're still interested in business analytics, you're going to do just fine. because there's a whole heck of a lot more to business analytics than statistics. But having these flexible, capable business analytics professionals enables organizations to address business problems so much faster. So a few key terms to remember as we're talking about and investigating data management. The first is data wrangling, and this is the process of retrieving, cleansing, integrating, transforming, and enriching data to support subsequent analysis. So here is where we transform raw data into data that we can actually use to conduct an analysis. We want to improve the data quality, reduce the time and effort required to perform analytics, and really reveal the true intelligence that's hidden within the data. Data management is the process an organization uses to acquire, organize, store, manipulate, and distribute data. And databases are a collection of data logically organized to enable easy retrieval, management, and distribution of data. And if these concepts seem really interesting to you and you haven't already, I strongly recommend you consider taking MIST 351, which is all about data management and databases and can turn you into a real master of data management. And trust me, the demand for that is real in the workplace. So the most common type of database is a relational database. And a relational database is probably fairly familiar to most of you, whether you've worked in Access or even just with spreadsheets. Relational databases look at things sort of in a row and column type organization with perhaps different tables that are linked and related to each other. So a relational database is one or more logically related data files called tables or relations. Each table is a two-dimensional grid made up of rows and columns. A collection of related fields makes a record, which represents an object, event, or person. A database management system is a software application that we can use to manage databases. Very common database management software that has been used for many years now is Microsoft Access. However, MySQL and SQL Server are starting to supersede Microsoft Access in terms of popularity as database management tools. Data modeling is the process of defining the structure of the database. If we're working with a database that requires multiple tables, and many of them do, and I'll show you an example in just a second, it's really important to understand how and where to place different elements of data and figure out how to meaningfully manipulate and extract this data. Relational databases are modeled in a way to ideally offer flexibility and make data retrieval very straightforward. And the entity relationship diagram is a graphical representation illustrating the overall data structure. And entities have relationships with one another. These can be one-to-one, one-to-many, or many-to-many. The primary key is the attribute that identifies each instance of the entity used to create a data structure called an index for fast data retrieval and searches. So when we have a key, it means that the same field appears across multiple tables, and you can use that to link those tables together. So in this scenario, each entity is represented in a box in which the attributes of the entity are listed. Each entity has a primary key, an attribute that uniquely identifies each instance of the entity. For example, the customer entity uses customer ID as the primary key because each customer would have a unique ID number. Order has another type of key, a foreign key. For example, because customer ID is the primary key of the customer entity, which shares a relationship with the order entity, It is considered a foreign key in the order entity. The pair of primary and foreign keys is used to set up the one-to-many relationship between two entities. By matching the values in the customer ID fields of the customer and order entities, we can quickly find out who places which order. Then in the order detail entity, two attributes, order ID and product ID, together create a unique identifier for each instance. We call this a composite primary key. The data model on the previous slide can be converted into database tables, and this figure illustrates summaries of the tables that could be created based on the structure established in the previous slide. So here we see our customer table, our order detail table, and our product table. And take a look to see which fields exist on more than one table, and realize that these are ways that we can connect these tables together in a large working database. Once data are stored in a relational database, we can retrieve them using database queries. Structured query language, or SQL, or SQL, is the most common query language. And we like it because we can use it to manipulate data using a simple and intuitive approach. There are three key functions that we can use to find and extract data from a SQL database. The select function specifies the attributes of interest. From specifies the table or tables, there can be more than one. And where specifies the selection criteria and or conditions that we are wanting the data that we're looking for to meet. So here's an example of some SQL code. The first query is simple and will provide you with some information, but we often need data from more than one table and apply more than one selection criteria, as illustrated in the second query. Some of you already have SQL experience, especially if you've taken MIST 351. My question for you is, do you find these commands intuitive? Would you have found them intuitive before you had that experience with your database class? I think that's up to every individual data analyst. And like I said, there are a lot of different and very important roles in data analytics. And what may be intuitive and easy for one analyst may not be the same for another. But don't worry, there's so many roles and things that we need to do that if one area is not your innate strength, we have others. There are plenty of toys to play with in data analytics. So relational databases provide a very efficient and effective way to manage data, but different business units have their own individual isolated databases, and it can be very challenging when multiple organizations and groups have their own databases that don't connect to the databases in other parts of an enterprise or organization. So some organizations have addressed this issue by developing data warehouses or enterprise data warehouses that act as a central repository of data from multiple units within an organization. And while this can be a very large undertaking, there are some benefits to this. That databases across the organization are integrated and accurate. It makes it easier for managers to make higher quality decisions. Databases and tables can be organized around thematic concepts that may transcend specific units within an organization, like sales, customers, or products. It is also easier to gather a historical view and a comprehensive view of the entire organization. To integrate data from the different databases in the different departments, the ETL, or extraction, transformation, and load process, is used. And this retrieves, reconciles, and transforms data into a consistent format that can be loaded into the final data warehouse and have utility for the entire organization as opposed to maybe one person, one unit, or one department. Data marts are sort of an intermediate between a database and an enterprise data warehouse. And these are small-scale data warehouses, a subset of the enterprise data warehouse, if you will. And it focuses on one subject or decision area. And it may conform to a multi-dimensional data model or a star schema. And I'll show you one of those in just a second. And it's not uncommon to see multiple fact tables sharing relationships with a group of dimension tables in a data mart. We like star schemas because they can slice and dice data based on different dimensions, and that can be very helpful when we're focusing on just one subject or just one decision area. So this is an example of a star schema. This is a specialized relational database with two types of tables, dimensions and fact tables. Dimension tables describe business dimensions such as customer, product, location, and time, while fact tables provide facts about business operations, often in a quantitative format. Each of the dimension tables has a one-to-many relationship with the fact table, and primary keys of the dimension table are also the foreign keys in the fact table. Combinations of the primary keys of the dimension tables form the composite primary key of the fact table. And the fact table is usually depicted at the center, surrounded by multiple dimension tables, forming the shape of a star. And that's how we get the name of a star schema. Now, there are new forms of databases being developed to help support the idea of big data that's emerging. One example is Nosql, which means not only SQL. And these refer to non-relational databases that can support the storage of a wide range of data types that may not be easily organized in that row and column format. So these types of databases can handle structured, semi-structured, and entirely unstructured data. And they are able to handle extremely high volumes of data. What we're finding is that Nosql is often implemented alongside relational databases to support organization data needs. So once raw data are extracted from the database or data warehouse or data mart, it is up to the analyst to review and inspect the data set to assess quality and relevance for subsequent analysis. And some common basic approaches that we might take are visual inspection, counting, and sorting. Counting and sorting data helps us verify the data set is complete, or it will reveal missing values. Sorting data also allows review of the range of values for each variable. Sorting data based on a single variable or multiple variables. So at this point, I challenge you to take a look at that customer data set in Excel again and use visual inspection, counting, and sorting to see if there's any data that may be missing. Maybe use the COUNTIF function to see how many males and how many females are in the data set. Or use the min, max, or a sort function to look at the range of household sizes or household income represented in the data set. I'm going to leave you there, and next time we're going to talk a little bit about data preparation.